120 between A and B, and one is 120 pound per foot between C and D. We have one concentrated load of 100 pounds as well, acting at PS. So looking at our procedure, how to find out the shear values, we just need to find out the shear values at point A, B, C, and D. This was simple. We computed VA was 170 because the direction of A at A was 170. Then we just computed the change in the area of the load diagram that we computed. So it came out to -70. Then we added 100 into it. It became -170. Then another point of -170. Then a point of 240, and then a point of 0. So we have 1, 2, 3, 4, 5, 6 points that we just computed from the area computations. The next point was how to get these points. We looked at the variation of the load. The variation load was constant, so the slope has to be constant. So we connected with straight lines. Load was constant, 0 load, so 0 slope in this one. So we connected these 2 points with a straight line. Similarly, between C and D, the load was continuously, uniformly varying, so it was a constant. Now we move to the bending moment diagrams. We'll do the same thing. Now we use this shear diagram, the areas of the shear diagrams, to compute the moments. This is our strategy. So starting at point A, looking at right at point A, there is no area to the left side of this one. So this will be a 0. Between this point to this point, that is at B, we have a variation. But again, the same problem happened, that moving between A to B, the shear diagrams crossed or changed signs from positive to negative. So we must know this point as well, because we know this would be a point of the maximum bending moment. Again, just like the previous one, we can compute using simple principles. If this distance is x, suppose from here to here, if this distance is x, this distance will be 2 minus x, because distance between A and B is 2. So this is x, this will be 2 minus x. These two triangles are similar triangles, so I can write the ratio. So I can write 170 over x, or x over 170, just like following here. So x over 170. So this divided by this equal to this side, that is x 2 minus x over 70. So we wrote down this equation, the answer came out to be 1.42. So this distance is 1.42. And we will compute our bending moment. So we need to find out at point, let's call this point at x, just like here. So change in area, so 0 plus, same, 1 over 2 multiplied by 170 multiplied by 1.42. The answer will be 120.42. So you draw 1 point here. Again, between this point and this point, we will find out the moment. So MB will be MX plus the area of this smaller triangle. So 120.42, and then subtract this, because this is being subtracted. Area of this triangle, the area of this triangle will be 1 over 2 multiplied by this distance multiplied by the height, that is minus 70. So this came out to be 100. So you have third point of 100 as well. So draw that point. Then at C, just like this one, so we will find out the value at B plus the area of triangle. Area of this, not triangle, but area of this shape is simple to find out. It's 170 multiplied by this distance of 2. So minus 240. So you have another point of minus 240. Then at D, you compute this one, the answer came out to be 0. So very simply, we had the bending moment points coming out as 0. This point of 120.42, at point X of 100, at point B of at point X was 120.42, then at point B was 100, and then at point C was minus 240, and then at D was 0 as well. So we have connected the points, and the next thing becomes how to connect these 2 points. So looking at this thing, the slope has to be positive, but with the decreasing slope. So positive slope decreasing, continuously decreasing. So this is how it will connect. Look at this curve. It is positive slope with decreasing slope values, because it moves from the maximum slope of 1 and ends up at 0 here. Between this, increasing slope in the negative direction. So increasing slope, slope is continuously increasing, but in the negative direction. This would be the part. Then between these 2 points, this is a constant variation, so we'll connect with a straight line. So this between 100 to 240, you will connect it with a straight line. It's not a curve, because the load, the shear diagram in this one is just a straight horizontal value. Similarly, continuously decreasing shear, positive values. So positive values, positive slope with continuously decreasing slope. So this will become maximum slope of 1, and then the value of would be 0. So we can connect all these points, and that would be this. Any question on this?
No, sir.
Yeah, it's easy to understand. I think it's not difficult, and that would give us an opportunity to quickly do a couple of more problems. But if anybody has a problem, just let me know. So we'll do one more problem and see. Fine. Let's try to understand this 431, or maybe something else that has a moment built into it as well. So 432. Similarly, we have a simply supported beams supported at 2 points, R1 and R2. One constant varying load of 40 kilonewtons per meter over a load of over a distance of 3 meters. Then we have a couple, already a moment of 120 kilonewton. That is a clockwise moment that we, I think, defined as positive. We'll see. So it's a clockwise moment already applied at this point on this one. Then we have a concentrated load of 60, and distances are given. Obviously, the first point will always be to find out the reactions R1 and R2. We know how to do this. R1 plus R2 would be equal to 60 plus 40 multiplied by 3, 120. So 120 plus 60. So you can find out R1 and R2. R1 is computed as 132, and R2 is computed as 48. They have not used that equation of R1 plus R2 equal to something. They have computed the moments once at a point against this one, and then one at this point. So that will be, so we have points A, B, C, D, and E. So one moment is computed as B, and one moment is computed at C. So one at reaction R1. So anyways, you can do this. So R1 and R2 are computed as 132 and 48. So moving to the shear diagram, we can look at this one. So starting with this VA. VA, we have a negative load of 60 kilonewtons, so VA will be minus 60. VB, this will be minus 60 plus the change in load between A and B. Change in load between A and B is 0, so it will be minus 60. So VB is 2. At B, we have another load of, that is reaction load, 132. So I will compute VB2 as well. So minus 60 plus 132, so 72. So far we have 3 points. One point was minus 60 at A. Then at B, I also have minus 60 point. Then at B, we'll have 2 points. So 1 point was minus 60, 1 point was 72. So we compute 72 as well. So